Hi everyone, in this video we're going to solve compound inequalities with the word OR. Such inequalities consist of two or more individual inequalities with the word OR written in between them. So this is one compound inequality. To solve this compound inequality, we start by solving each inequality separately. To solve the first one, I simply have to get x by itself, and for that I'll need to subtract 3 from each side. So I'll get x is less than or equal to 2. In the second inequality, to get x by itself, I'll need to add 2 to each side. X is greater than or equal to 5. In the second step, we're going to graph both solutions on the same number line. Since the first solution is x is less than or equal to 2, I'm going to place the closed circle at 2 and highlight to the left. The second solution is x is greater than or equal to 5. I'm going to place the closed circle at 5 and highlight to the right. This is where I have values that are greater than 5. And then to obtain the solution to the given compound inequality, I need to find the union of those two solution sets. In math, the union of two or more sets is a set that combines all values from all sets. So on the graph, the union will represent the highlighted portions of the number line. In other words, everything that's highlighted will be part of the solution. And this is how I like to think about it. If I'm solving a compound inequality with the word OR, that represents union of the individual solution sets. And from the number line, I have to take everything that's highlighted. So I have two portions that are highlighted. That's one on the left and this one on the right. Well, both of them will be part of the solution. So this is how I'm going to write the answer using interval notation. First, I'm going to describe the interval on the left. It starts at negative infinity and goes all the way to positive 2. Here's the corresponding interval notation. And then I'm going to describe the interval on the right. It starts at 5 and goes all the way to positive infinity. Here's the corresponding interval notation. And since I ended up with two intervals that represent the solution to the given compound inequality, I will have to use the union symbol in between them. So that's how we're going to write the solution using interval notation. Let's try another example. We start by solving each inequality separately. To get x by itself in the first inequality, I'll add 25 to each side. This will give me negative 4x is less than 40. And then I'll divide by negative 4 on the left and on the right. Because I'm dividing by a negative number, I need to switch the inequality symbol. So it's going to be x is greater than negative 10. Now in the second inequality, to get x by itself, I'll add 3 to each side. 7x is greater than or equal to 7. Then I'm dividing by 7 on the left and on the right. So x is greater than 1. Next, I'm going to graph both of the solutions on the same number line. I place an open circle at negative 10 and highlight to the right because x is greater than negative 10. For x that's greater than or equal to 1, I'm going to place the closed circle at 1 and also highlight to the right because it's greater than or equal to 1. And after I graph both solutions on the same number line, I have to find the union of solution sets. Here I'm going to remind myself that union is represented by the highlighted portion of the number line. So everything that's highlighted, that's going to be a part of the solution. And I don't care if it's double color or single color, if that portion of the graph has some kind of color, it's going to be a part of the solution. And here I can see that everything to the right of negative 10 is highlighted. So that's going to be the solution. I have to describe this portion of the number line using interval notation. Well, this highlighted portion starts at negative 10, and I use parentheses right next to negative 10 because of an open circle. And then it continues all the way to positive infinity. So from negative 10 to positive infinity. This is going to be the final answer. This interval represents a solution for the given compound inequality. And let's repeat all the steps for our third example. Let's start by simplifying the first inequality. First, I need to distribute 2. So that's going to be 2x plus 2 minus 5 is less than or equal to 4. And I'm going to combine like terms. I'll get 2x minus 3 less than or equal to 4. To get x by itself, I will add 3 to each side. 2x is less than or equal to 7. And finally, I divide by 2 on the left and on the right. So x is less than or equal to 7 over 2. For the second inequality, I have to do similar steps. First, I'm going to clear the parentheses by distributing -1. That negative sign is the same as -1, so it's going to be negative x minus 3 less than or equal to -2. To get x by itself, I start by adding 3 to each side. Negative x is less than or equal to +1. And then to get rid of the negative sign in front of x, I'm going to divide by -1 on the left and on the right. Don't forget that when you divide both sides of the inequality by a negative number, you have to reverse the inequality symbol. So I'll get x is greater than or equal to -1. I solved both inequalities separately, and now I'm ready to graph the solutions on the same number line. The first one is x is less than or equal to 7 over 2. So at 7 over 2, I'm going to place the closed circle, and I will highlight to the left of 7 over 2. I'm highlighting all the way to the end of the line that I have here. The second solution is x is greater than or equal to -1. I have to put closed circle at -1. And because it's greater than or equal to -1, I will be highlighting to the right. Again, all the way to the end of the line that I have drawn here. To determine solution of the compound inequality with the word or, I have to find union of those two individual solution sets. The union of the solution sets is represented by the highlighted portion of the number line. And what is highlighted here? Well, it looks like the entire number line is highlighted. Remember, I don't care if it's single color or double color. If it's highlighted, it's going to be part of the solution of the compound inequality. How do we describe the solution using interval notation? Well, again, this graph shows that all numbers on the number line will represent solutions of the given compound inequality. In other words, it's the interval that starts at -infinity and goes all the way to +infinity. So as you can see, when you solve compound inequalities with the word or, you can get different types of answers. What's going to help you to get the right answer is to remember that the union of the solution sets is represented by everything highlighted on the number line.